Hello guys, and welcome to the second episode of sturm liouville problem. Like I said in the first video I said I was going to explain the second question to you, right? And this question is very important that you know it because a lot of people don't really have the solution to this question. I'll explain it vividly how you can solve this, and trust me, you're going to get it just as usual. So if you're new here, welcome. But please, I'd like you to subscribe to my channel and then also turn on your notification bell to get notified immediately I upload other videos. Trust me, you're going to enjoy this video. And then if you do really enjoy the video at the end, do like my videos, and if you have any question you can comment. Thank you. Now let's go to the main thing here. We're trying to solve this sturm liouville problem. And what did I say when I was solving sturm liouville problem? I said we're always looking for eigenvalue and what vector function, excuse me. But now, what is your eigenvalue? I said your eigenvalue is your lambda, right? And then your eigenfunction is your function y of x. I've explained that before in my previous video, so if you're new here, you might probably have to watch my previous video for you to understand better. But trust me, just kind of follow us here, you still get it. So now to solve this question or differential equation, we have x y prime plus lambda over x y equals what? 0. Now if we want to solve this, what I'll first do is this is like me saying d dx, so I have to differentiate this once. So you're having product rule, so I differentiate one, leave one. So now you have differentiate x, I have 1, and leave y prime, plus leave x, differentiate y prime, you have what? Y prime plus lambda over x y equals 0. Now I don't want x to be in the denominator, so I kind of want to multiply all through by x. So therefore I'll have this to be y prime x plus x squared y prime plus lambda y equals what? 0. So when I have this, I can decide to rearrange. So I have x squared y prime plus x y prime plus lambda y equals what? 0. So now let me call this my equation 1. Notice that this is different from the previous one we solved. The previous one was straightforward. All we had to do then was kind of to change it to quadratic equation, again find your roots to know if it is probably real and distinct, if it is real and repeated, and if it is complex, for you to get your y homogeneous, like your general equation. So now to solve this is different. To be using Cauchy-Euler's equation or Cauchy-Euler's method to solve this. You can't just, that's like the best way to solve it right now. So now to solve this, I'm going to use second order Cauchy-Euler equation, which is that we have our a2x squared y prime plus a1x y prime plus a0 y equals 0. So let me name this equation 2. Now if I have this to be equation 2, and then I'll compare equation 1 and 2, notice that my a2 equals 1, which is the coefficient of x squared and y prime double prime. Coefficient of x squared and y double prime here is what? 1. So I have a2 to be 1, my a1 to be 1, and my a0 is the coefficient of y, which is what? Lambda. So I keep this. Now I recalled from Cauchy-Euler equation, knowledge from Cauchy-Euler, that you have your p of m, which will later be equal to 0, is going to be equal to a2 m squared plus a1 minus a2 m plus a0. Now, which is, I said this is going to be equal to 0, so which is a2 m squared plus a1 minus a2 m plus a0 equals what? 0. Now this is going to reduce to a equation that I'll be able to solve and get my root. So I said if you are working with sturm liouville problem, what we need to do is we have to look at 3 cases, right? So the first case is, you can decide, the first case is when you have lambda equals 0, lambda equals, second lambda less than 0, and third one lambda greater than 0. Now let's deal with the first case, when lambda is less than 0. And so case 1, when lambda is less than 0, that means I can say let my lambda equals minus p squared, or you say lambda equals minus lambda. I've explained this before in the previous video, so I'll be using this now, which I promised to use now. But before that, let me go back to equation 1. Equation 1 has x squared y prime prime plus x y prime plus lambda y equals 0. Now, since I said a2 is 1, a1 is 1, a0 is lambda, so using this equation, I'll have a2 is 1, so I'll have m squared. We reduce this. a2 is 1 for this. If you compare this and equation 2, a2 is 1, a1 is 1. So plus, since a1 is 1 and a2 is 1, 1 minus 1 will end up giving us what? 0. So I have 0 times m, which is still 0, plus a0. What's your a0 here? Lambda equals 0. So I have m squared plus lambda equals 0. Now for my case 1, I said if lambda less than 0, it implies let lambda equals what? Minus p squared. So I have m squared minus p squared equals what? 0, which implies I'll have m squared equals what? P squared, which implies that my m equals, so I have m equals plus or minus square root of what? P squared, which means which implies m equals plus p or what? Minus p. So now, unlike the normal way we know how to solve to get a general equation, here it's a bit different. You can't just say, normally we just say, since you have two roots, normally you can just say y equals c1 e raised to power minus p plus c2x c2 real and different, c2 e raised to power p x, right? But here, if you're working with Cauchy-Euler, it's a bit different. So let me explain it to you. If you have m1 to be x and mp to be minus p, the solution will now be y equals c1, instead of e raised to power, you now have x raised to power the first root p plus c2 x raised to power the second root is what? Minus p. I hope you're getting it. So you'll be using x raised to power your roots for Cauchy-Euler. Now I already have y equals this as our general solution. Let me call it equation asterisk. Now you can input your conditions. The first condition is y prime of 0 equals 0. That means if you notice our question, we have y prime. That means we have to differentiate our y by function once. So we now have y prime to be equal to, if you have x raised to power p, same thing as having x raised to power what? X raised to power p, same thing as having x raised to power 2. So if you differentiate x raised to power 2, what will you have? 2x. So we have 2x 2 minus 1, right? Or 3, if you to differentiate x raised to power 3, we'll have 3x 3 minus 1. So if you have to differentiate x raised to power p, it is px p minus 1. So yeah, I'll have p c1 x raised to power p minus 1. This one will be minus p c2 x raised to power minus p minus 1. So now I can put my boundary. So y prime equals 0 and x equals 0 from here. So I will then have 0 from this equation a. I'll have y prime is 0, so 0 equals p c1. Your x is what? 0, so it should be 0. The condition is y prime of 1 equals 0, because if you have y prime of 0 equals 0, this will not go well, right? So now I've changed it to 1. So if you have the condition to be y prime of 1 equals 0, then here would have y prime equals 0 and x equals what? 1. So from this equation a, I have 0 equals to p c1 1 raised to power p minus 1 minus p c2 1 raised to power minus p minus 1, and 1 raised to power anything is still 1. So I have 0 equals to p c1 minus p c2. So this is the same thing as PC2 equals what? PC1. P we cancel P. It implies C2 equals what? C1. So I have this first. Now going to the second condition, y prime of e raised to power 2 pi equals 0. So I'll have y prime of e raised to power 2 pi equals 0. So it implies my y prime equals 0 and x equals e raised to power what? 2 pi. So from equation A, anywhere I see y prime I put 0, and anywhere I see x I put e raised to power 2 pi. So I have PC1 e raised to power 2 pi into brackets p minus 1 minus PC2 e raised to power 2 pi into brackets minus p minus 1. And we said C2 equals C1, so I have 0 equals, or C1 equals C2. So let me use C1 equals C2. So I have PC2 e raised to power what? 2 pi into p minus 1 minus p C2 e raised to power 2 pi into minus p minus 1. So here, just like we did here, p we cancel p, or let me show you. This is going to be PC2 e raised to power 2 pi equals PC2 e raised to power 2 pi. So p we cancel p. Or let me just do this way so you understand. So here I have 0 equals, C2 is common, so I have PC2 is common, so I have e raised to power 2 pi p minus 1 minus e raised to power 2 pi minus p minus 1. So let me keep this here. So your C2 is going to be equal to 0, but e raised to power 2 pi multiplied by, let's say your p is 1, 2, 3, 4, 5. It can never be equal to 0, because normally your e raised to power 1, your exponential e raised to power 1 equals 2.71 blah 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 in mathematics. So it's never going to give you 0 if you subtract. So even if your p is 1, 2, 3, 4, 5, so your C2 is going to be 0. If C2 equals 0, it implies that your C1 is also equal to what? 0. Now if I have C1 and C2 to be equal to 0, then it implies I can't get my desired eigenvalue and my desired what? Eigen function. So therefore I'm going to have to look at case 2, and my case 2 is when lambda equals 0. So when lambda equals 0 for case 2, remember from equation 1 we have x squared y prime prime plus x y prime plus lambda y equals what? 0. So here I'd have x squared y prime prime plus x y prime equals what? 0, because lambda is what? 0. So I can decide to use another method to solve this, or you decide to use the other method, the Cauchy-Euler method. So let me show you something here which I've done before. So here you just have x squared y prime prime equals minus x y prime. So here I have y prime double prime equals minus x y prime over x squared. So I have y double prime over y prime equals minus 1 over what? X, which implies I'll have, so if I integrate both sides, I've done something like this before, that's why I'm doing it again. So if I integrate both sides now, if you differentiate what you have down and it's giving you, like, let me show you. If you have 1 over x, the reason you have ln of x anytime you integrate 1 over x is because if you differentiate x, what will it give you? To give you 1. So anytime you differentiate your denominator and it is giving you your numerator, it means you're going to have ln of your denominator. So now the denominator here is y prime. If I differentiate y prime, I'll have what? Y double prime. So it's going to be, that means I'll have here to be ln of the denominator y prime equals minus ln of what? X plus your what? Constant. So here I have ln of y prime plus ln of x equals what? K. So I have ln of y prime x equals what? K. So my ln, so I take exponential of both sides. I have e raised to power ln of y prime x equals e raised to power k. So here I'll have y prime x equals k1. You say where your k1 equals e raised to power what? k. So now I'm looking for y, not y prime, so I can still integrate. If I integrate both sides, I'll have y. Oh no, not yet, you can't integrate now. So we have y prime x equals k1. So y prime equals k1 over what? X. Now you can integrate. So if I integrate both sides, I'll have y equals k1 ln x, because you have 1 over x, plus what? K2. So let's say I want to change my constant to c1, c2. So I have y equals c1 ln x plus c2, where your c1 is k1, your c2 is k2. So let me take this as my equation b. Now I can put in my condition, but don't forget your condition is what? In prime, like you have to differentiate one. So that means I have to differentiate my equation once. So here I'll have y prime to be equal to, you don't even need this because we already have y prime to be equal to what? K1 over x here. So since your y prime equals k1 over x, now putting your condition, the first condition is what? We have y prime of 1 equals 0. That implies that your y prime equals 0 and your x equals 1. So I have 0 equals to k1 over 1, which implies that my k1 equals 0. If you do for the second one too, you still have 0. Like if you do the second one, y prime of raised to power 2 pi, you see, to still give us 0. So we'll still have our k1 to be 0, which does not give us our desired eigenvalue and eigenvector. So now let me go to case 3. So for case 3, when our lambda is positive, so that means it's equal to, when it was negative, we used minus p squared. So when it is positive, we want to use p squared. So I have lambda equals p squared. So from the first equation, just like we did this one, we have x squared y double prime plus xy prime plus lambda y equals 0. So if my lambda is equal to p squared, I'll have x squared y double prime plus xy prime plus p squared y equals 0. Then we'll use Cauchy-Euler's equation, the second order. So the second order is saying you have a2x squared y double prime plus a1xy prime plus a0y equals 0. So from here, if I'm to compare equation I and equation II, notice that my a2 equals 1, my a1 equals 1, and my a0 equals what? P squared. So using this form, P of m, which I've explained before, a2 m squared plus a1 minus a2 m plus a0, we have our P of m equals a2, and I say your P of m equals what? 0. So your a2 is 1, so I have 1m squared plus 1 minus 1 is 0m plus p squared. So here I have m squared plus p squared equals what? 0. Now if I have m squared plus p squared equals 0, it implies that my m squared equals minus p squared. Now if my m squared equals minus p squared, I'll have m to be equal to plus or minus square root of minus p squared, which is going to give us, which implies my m will be plus or minus ip. Oh yeah, ip. So now let me first give you your general solution, your y homogeneous anytime you are solving using Cauchy when you have complex, so you understand what I'm saying. If you have m to be equal to a plus ib, it implies that you have your y homogeneous to be y equals x raised to power a into bracket c1 cos b ln x plus c2 sine b ln x. So if I'm to compare now, I notice that my a is 0 plus or minus, a is 0, so your b is what? P. Because if I write this as m equals 0 plus or minus ip, notice that your a is 0 and your b is what? P. Then your y here is going to be x raised to power 0 is 1, so you don't need to write x raised to power 0 again. So I have c1 cos, what's your b? P ln x plus c2 sine p ln x. Do you get it? Now you can name this equation I. So if I name that equation I can easily put in my conditions. The first condition is what? You have y or prime of, using the question, we have y prime of 1 equals what? 0. So since y prime of 1 equals 0, it implies I have to differentiate this, right? So if I want to differentiate this, we have our y to be equal to c1 cos p ln x plus c2 sine p ln x. So once you differentiate this, I'll have y prime to be equal to, so if you differentiate cos, you have what? Minus. So I have minus c1. Sorry, if you differentiate cos, you have sine. But now look at this clearly. Let me explain this to you. Differentiate p ln x. And if you have differentiate cos 2x, what will it give you? You have 2 sine what? 2x. Why? Because you differentiate what you have in front first. And if I differentiate 2x, I'll have what? 2. If I differentiate cos 2x squared, I'll have differentiate what you have in front. I'll have 4x, right? So I have 4x, then I'll write my differentiate cos, I have what? Sine the question back. Do you get it? I hope you understand. So if you have this, then it implies if I want to differentiate cos p ln x, if I want to differentiate cos p ln x, that means I have to differentiate everything in front, which is p what? Ln x. So if I differentiate using product, we differentiate p0, differentiate ln x, you have what? 1 over x, opposite of integration, then you cross multiply. This will be p over x plus 0, which is what? P over x. So that means if I differentiate cos p ln x, I'll have p over x. Differentiate cos, you have what? Sine, then your question back, p ln x. I hope you understand. It's so straightforward. If you have any question, you can let me know. So here we have plus, okay, let me write this back. So you're going to have p over x c1 sine p ln x plus p over x c2. If you differentiate sine, you have what? Minus cos, right? So I'll have, if you differentiate cos, you have minus sine, and you differentiate sine, you have, if you differentiate sine x, you have what? Cos x. So have cos p ln x. So that means our y prime, if I write it, will have minus p over x. It's common, right? c1, because if you differentiate cos, excuse me, you are supposed to have minus sine. Don't mind me. So you have sine p ln x plus c2 cos p ln x. So now we're going to have to put our condition, and the first condition is what? Y prime of 1 equals what? 0, which implies your y prime equals 0 and your x equals 1. So I'll have 0 equals minus p over 1 c1 sine p ln 1 plus c2 cos p ln 1, and ln 1 equals 0. So if ln 1 equals 0, I'll have, oh sorry, let's plus p, so you have minus, so it won't tamper out anything. So minus c1, if you had minus here, the sign here will change to minus, so I don't want to change the sign here. So let's continue this way. So but then ln 1 is 0, so if ln 1 is 0, you have 0 times p to be 0, then sine 0 will be 0. If sine 0 is 0, then c1 automatically be 0 here. So I have 0 plus c2 cos 0. Why? Because lane 1 is 0. 0 times p is 0. Then it implies I have 0 equals p c2 cos 0, and cos 0 is 1, so I'll have 0 equals to p c2, which implies that my c2 equals 0. We divide both sides by p. Now I already have c2 equals 0. Going to the second condition. And what is the second condition? The second condition is y prime of e raised to power 2 pi equals what? 0, which implies your x equals e raised to power 2 pi and your y prime equals what? 0. So putting it inside this equation f, I'll have 0 equals p over e raised to power 2 pi, and I open my brackets, minus c1 sine p ln e raised to power 2 pi plus c2 cos p ln e raised to power 2 pi. So here c2 equals 0, so I won't have c2 anymore. I have 0 equals to p over e raised to power 2 pi into bracket minus c1 sine p ln and e. If you have e ln e raised to power 2 pi, I'll have it to be equal to what? 2 pi. So here I'll have sine p 2 pi, or 2 pi p. Now if I take this other side, I have 0, so I have 0 equals minus p c1 sine p 2 pi. So let's say I have minus p equals 0, it implies that p equals 0, and then your c1 sine p 2 pi is not equal to 0. Now consider me having so your p equals 0, then my c1 sine p is going to be equal to 0 from here. Now if I have c1 sine p sine 2 pi p equals 0, it implies that my c1 equals 0 and my sine 2 pi p is not equal to 0. But if we have c1 equals 0 and c2 equals 0, we'll have problem, right? But then we can have condition whereby you have your sine 2 pi to be equal to 0, which I explained in the previous solution. So sine 2 pi p can be equal to 0 at what condition? It does only have one condition, where you have this to be equal to pi or multiples of pi. When I say multiples of pi, I'm saying using your sine graph. Here I have pi, I have 2 pi, 3 pi, so this is 0. At all points on the x-axis, your sine of anything there will be 0. Sine pi is 0, sine 2 pi is 0, sine 3 pi is 0. That means sine 180 is 0, sine 2 times 180 is 0, sine 3 times 180 is 0. So that means this 2 pi p, the only reason why it's going to be correct is when you have your 2 pi p to be equal to n pi, when your n is equal to 1, 0, 1, 2, 3, like that. So if you have this, it implies that if you have n to be 1, that means you have pi, which is 180. So if you put pi here, you have sine 180 to be equal to what? 0. Sine 360 to be equal to what? 0, which is true. So it's only when you have this 2 pi p to be equal to n pi, that's when you're going to have sine this to be equal to 0. So I can now say, since this is true, pi will cancel pi. So pi will cancel pi, so we'll have 2p equals n. Then you have your p to be equal to n over what? 2. Since I have p to be equal to n over 2, recall that we said from the beginning, what is our condition for lambda? We said we want our lambda to be equal to what? P squared, right? So said since lambda equals p squared, then I can say my p squared equals n squared over 2, everything n over 2 squared, then it implies that since my lambda equals p squared, what we're considering, then your lambda will now be n over 2 or what squared, which is our desired eigenvalue. I told you that your eigenvalue is your what? Lambda. Can you see the beauty of the explanation? And everything is so easy, right? If you have any question, you can drop it in the comment box. I will definitely reply to your question. Now remaining our eigenfunction. So I said if you want to get your eigenfunction, you go back to your equation. So our equation here is y equals to c1 cos p ln x. So I'll write it. Y equals c1 cos p ln x plus c2 sin p ln what? X. So we said our c2 is 0, so I don't need it. I'll just have my y equals c1 cos p. What's your p? P is what? N over 2 ln what? X plus 0, which is 0. So this your y, the same thing as y of x equals c1 cos n over 2 ln x, which is our desired eigenfunction. So let me just go through it one more time so you understand what I'm saying. It's already 30 minutes and it's long already. So the first thing we did was to check for different cases, right? We said we want to check for when case lambda less than 0 and it was not correct, like we're not getting our desired eigenvalue and eigenvector. So we then checked for when we had case 2, when lambda is equal to 0, it was not giving us our desired eigenfunction, eigenvalue. Then we checked for the third, which is when lambda equals p squared, when lambda is positive, right? So we had, then it gave us our eigenvalue and eigenvector while we went through all this, isn't it? So we had our eigenvalue, to be this, and our eigenfunction to be this. And let me quickly explain one more thing to you. Let's say we had here to be c1 cos p2 pi equals 0. Now this p2 pi, at what point will it give you 0? At when you have 2n minus 1 over 2 pi. Why? Let me explain it to you. Your cos, when you have cos pi over 2 to give you what? 0. Cos 90 is 0. Cos 3 pi over 2 will also give you 0. Cos 5 pi over 2 will give you 0. So if all this 5 pi, you can test it. 5 pi, that's 5 times 180 over 2. 3 times 180 over 2 to 45. Cos 45 won't give you 0. So you want to check, let's check for 3 pi over 2. That means your n, when your n is taking 0, 1, 2, 3, up like that. So if n is 2, I'll have 2 times 2, 4. 4 minus 1 is what? 3 over 2 what? Pi. So it's only when you have this p2 pi to be equal to design, that's when you're going to have this to be equal to 0. That's for cos. Then for sine, always equal to n pi. So I hope you understand the explanation. If you do like my videos and then subscribe. Thank you so much for watching. Have a nice day.